Okay, second session of the third day, so session number 8, related to special things, to Logic Engine, LUA scripting, XLogics, and the new logic module. Thank you, Bernard, for your support in the chat. So any question, please write it down, and we will be pleased to try to answer everything. But this is a special tools, so has to be explained slowly also. We have this session and the next one to finish if we don't have enough time to finish the examples of this session, because the next one is also easy to explain, are also new functionalities, the main backup, very important main backup, the clustering configuration, the cloud portal. So it's really fantastic complementary solutions of our BMS platform, but we have a lot of things to explain, so we may need some part of the next session for that, but don't stop. Let's go ahead. First thing to explain will be the LUA scripting. LUA scripting is a fantastic part of the BMS. Sometimes it's not very used for the integrators because two reasons. The main reasons for this not using of the LUA scripting. The first reason is that you may need some special knowledge about programming. Some cases, in my personal opinion, for me personally, it's not easy to do scripting because I miss sometimes a comma or a parenthesis, and it's complicated to check all these things. I'm not a programmer, I am an industrial engineer, so programming is a mystery in some cases. I am apprentice of programming, so I can do some basic things. So I'm not a dummy in these things, but when you are an expert in programming, it will be a really powerful tool for you. But the second reason that we not use every project the LUA scripting, it is always interesting, but sometimes it's not necessary. This is because we have another options for doing the same things. And these options are more and more commonly used. The main option that we have to substitute the LUA scripting is the XCommands that I will explain at the end of the session. That's fantastic because in this case, I am not bad doing using the XCommand and the XLogic tool because it's block programming. So I think I am much better doing such programming that doing or writing scripts. So for this kind of people like me, stupid people like me that is not able to do scripting as you may do, for us we have this fantastic solution that is the XCommand or the XLogic tool. But there is also a new one tool that is the logic module that is brand new. It's the first time we explain in a training, and it's also a nice discovery from my point of view because it's really easy to handle this kind of conversions or small things to do to create the new items, etc. So first of all, I will explain something about the LUA scripting. I will also create some examples, some real examples, so it can be useful. But at the end, we will see how these examples is much easier to do now with the logic module. So it will be interesting to see both things. So first, let's talk about the LUA scripting. LUA is an engine, or LUA is a language for scripting, a basic language for scripting that is possible to embed in other superior or more important softwares like the BMS platform. So it's embedded in the BMS platform, and it's very easy to find where is the LUA scripting for our workspace. We have a button, edit script, so we can open a folder that is containing all the scripting of this specific project. So if you see the path of this folder, you can see that the program is 64-bit, but it's included in the and 32 bits folder, NetX Automation, BMS Platform, Core Workspaces. This is the folder for the workspaces for the projects we are creating. I created one in the morning, it was with the date of that day, NetX Online Training. And inside this, there is some folders. One of that folders is the script files. This means that every single project has different scripting files. One good question is that if you do something wrong and you need to recover the default scripting files, it's not a problem. You can create a new project and copy paste that file, so you will have again the basic scripting files and go back to the previous situation. And another good question is that everything is here inside. So there is several files because we can also do different processes in parallel. This is also important because scripting, if you have all the processes in all the interactions in the same file, the interactions are a continuous succession of that. So they are executed one by one. So if you have an iteration, for example, to do some process from 1 to 3 million things, it will last some seconds to do this. So it's interesting to have some different threads in parallel. So this is the reason why we can open different files and process in parallel. This means that there is one main file that is the one that the Lua scripting is handling. This is the NXA definitions. So this is they are ordered by alphabetical order, but not for importance. This is the most important thing, NXA definitions. And if you want to call a process in parallel, you have to invoke that from this file. So I will open this. I will open the NXA definitions and show you how the rest of the files have been invoked from this. When you open it, it's open in the same BMS Studio. So this is the file, NXA definitions. There are some comments, so you can see the comments starts with hyphens, 2 consecutive hyphens. So it's that, and then some brackets if you want to do a multi-line comment. But with hyphens, you can write whatever comment with any problem. So it's not a problem. And then after the first presentation with some comments, you have the require block. That is what I mean. When you need to require a specific file for your specific scripts, you have to do it here. So if I want to create one example files for my training, I can do it here, but I can do it on the fly. So I just have to write my examples, for example, my Lua examples file, and just opening it, I am creating that file and opening that file. So it's very simple. I repeat, it's just open, edit the script, write the name of your file, and you will create it. So you can see it here, and you can open it at the same time. But this is not going to work if you don't require that file from here. So if you want this to work, you have to require your examples.lua, but .lua is not necessary. The extension is not necessary to write it. So this is the way to do this. If you want to create your own file, it's not a problem. You can do it here. We can do some examples here now, but we have to activate this file from the Lua engine doing this require. But before doing these examples that I will show you and do some things, interesting things, we can take a look on what we have in this main Lua scripting file. And this is very important also because we can do a lot of things with the Lua engine. We can create items in the very beginning of the creation of the item tree. We can initialize items with values, but this is a different, or is made at a different point of the initialization process. So this is the first thing you can see here is that 2 functions, on init event and on start event. So 2 different things can be done on init event and on start event. We have some examples here that we can maybe activate it. So they are in comment. So for example, on init event, it's explained here, this function is called on the initialization of the server process, the very, very first point of that. So the item tree is not yet fully initialized. So that's the time to create virtual or custom items. Maybe you remember from previous session that there was a branch in the item tree that it was called the custom branch. I can show you. Custom branch was here and is here for something. It's empty, but custom is the branch where you can directly create some specific items created by yourself. So how can I create an item? Well, we have an example, so we can use this example just releasing the hyphens. NXA dot means a function created by NetX automation. So this is what it means, the NXA. And there is a specific function that is called add custom item. And there is 5 things to do when you need an item. The first thing to do is to create a name. This is the name. The second is a description. So it's as a text. Then we can give the access if it's writable, readable, or all. So this is exactly for that. And it's very important with which type of data point we're going to create. It could be Boolean, it could be date or whatever. So this is the main things that we can create. And then the structure of the folders that contains that data. So it will be this data will be in floor 1 folder that is inside the building 8 folder that is inside the branch called custom. I will create now a copy of this. I will copy paste this, one of the best things in the computing, copy paste, but I will put my own item. A description. And I will show you some interesting thing here, some trick. We are here to know some tricks. Look, if I will show you this here. If you press the buttons Control and space, you trigger a list of options that you can write here. That's fantastic. Control and space. So you see all the functions that you have here in LUA engine. A lot of them are NXA, but some of them are not specific for NetX automation, are to manage IO information files or math operation or whatever. There is a lot of possibilities. And on this meaning, or following this example, if you filter and you write, for example, NXA dot and you press Control and space, you will only filter all the specific functions related to NX automation or created by NX automation for LUA engine. So knowing that, it's possible to know if I delete this and I press now with NXA.access dot whatever, I press the Control and space and I filter the options I have to choose. That's the trick. So you can also copy paste and investigate what is possible for you. Here, imagine that I want to create an only readable item, and the same thing here. I can also create a type. And what are my options? The 5 options we have, if you remember, in the bar branch. Booleans, dates, integers, that is number without decimals, reals, that are numbers with decimals, or strings that are text. Okay, so we can create, for example, a Boolean. Why not? A Boolean. And then the folder training, for example, and session 8, for example. This is the folder. So if I restart the server, this will be created during the init event process. So because they are inside this function on init event will do whatever, initializes xcon, I will explain now, and create 2 different items. That's fantastic. I will see the result after restarting the server. Okay, after this point, it's not possible to create items in principle. So the next step of the initialization phase is the start event. On a start event, this is also called during the server startup, but it's called after the initialization phase. So the item tree now fully exists. It's not possible to create an item because it has been created, the item tree. But the items can be initialized. We can give values to that items. And also we can also assign, attach tasks to these items. So tags, logic tags, or whatever. So you have here some examples that we can also reuse. We are very, very smart reusing things that other created. So for example, set value. So what is the item? The item is nettext var boolean item number 1. Okay, we can use this item number 1 and put it to true. Let me copy this and, for example, the item number true, I will put it to false. It's very simple to see afterwards. And also we can, for example, if you remember, we use in the LAMPS module one integer value number 1, and we normally assigned it 200 milliamperes. So we can do it now from the beginning. On a start event, we can put this value from the very beginning, so we don't have to remember to do this every time, because we can do it from the beginning. One single thing about this, you can see that the item structure from the item tree, for example, that var boolean number 1, the real item is with only single backslash. This is the backslash. Okay, nettext backslash var backslash boolean backslash item. In Lua, the backslash has a specific meaning, so we need to put a double backslash. So this is the only comment about this. So you see here that the item ID is a bit different than the real one that you can see in the properties window, because it's a double backslash, but this is just a small thing to remember. Okay, we can also write a value to a real item. So you can go to room 0101 and write, for example, the value 010 is the on 011, sorry, is the on for the lights of this first practical board of the first room. We can also use the alias, of course, for this. So we have also possibility to use an alias for this. So I will turn on also the last room of the second floor, central off. This is my item. So it's much easier maybe to take this and use, instead of that, use this with double backslash. Okay, for example. So that's things that we can do easily. We can also use logics, for example, but logics is more easy for us to use with the blocks, with XLogics, with the commands that we can do using blocks. So there is one advantage is to use logics with Lua. You have no limits in the number of inputs. You can have a OR gate with 70 inputs, and that's a bit more limited in the XLogic because of the resources of the tool, but it's also a bit more complicated to do these logics here in Lua. And this is the things that we can do or test with the Lua scripting, basic things. But the process is also completed with a stop event, script init. It's also possible to do something when the script init or when the script engine is starting. For example, I can show you that we can create, there are some possibilities to write in the log info, for example, write something in the log. So you will see down in the system message window, hello from Spain, for example, but in text format. And if I save and restart, something is not well. Example. My mistake. I put examples in plural. It was my mistake. Now it's working. It was my mistake. So you can see here in the log, hello from Spain. This is a text. Every time you reinitialize the script engine, you will see this, for example, on script stop, on second timer, every second. You can also execute whatever every second, whatever every minute, whatever thing every hour. So you can do these kind of things to cyclical events or whatever. So it's there are many other options to use the timing. So it's not necessary to do here. But if you want, you can do a script and consider a second timer event, create a counter and execute everything. If the counter is 15, so you can create a script with every 15 seconds or whatever. So it's totally customizable. And there is a lot of possibilities also about the client connections. Client means the visualizations. Client means the OPC clients. It could be web clients or visualizations. So it's really possible to know if a client is connected. You can do several things. If a client is disconnected, you can do also several things. So it's also possible. So this is the one small approach of what we can do with the LUA scripting, and we can do some examples now. But before I will reinitialize the server, restart the server, so you can see the result. We should have the lights from the last practical board turning on, and we can see the item tree that if it's executed, and we can have some items set also from the BMS when it starts, and we should see 2 new items because we have created 2 new items from the very beginning in that process, in that initialization process of the BMS. So it's also possible. And then we can do some examples for you to understand how it is working, for example, before we deal about the new logic module that is also very, very interesting for many of you because it's new and it's also very powerful. So it's starting, and let's see if my small changes works. Now, here we are. So what happened with custom? Yes, we have some items, new items. This is the one that was created by the computer before. It was a real with read and write. So you can see here the properties. It's a real value with read and write possibilities. What about my item? Okay, my item, it's in custom. It's the training session 8, and the name on the description is here. And you can see in the properties that it's a Boolean and it's read only. That is exactly what I decide to configure for this. So that's good. Also, we should find here in the Boolean, the first in true and the second in false, correct? So we set these values from the very beginning. And also in the numerical, oh, this is not working. Okay, numeric. Maybe I did something wrong with this. Yeah, I write integer. Sometimes I'm very funny. My mistake. Okay, it's numeric. I think I have to restart again the server to see this working. I put integer. Okay. So let's restart the server and check it so we can advance with the other examples. Very interesting to take a look on that. So lasts a bit, even every time we include more and more functionality, it takes a bit more milliseconds to restart, but it's okay. Let me start also the knowledge base because it's interesting for us to find information about, okay, for the next. So I made another mistake. It was again my mistake because I'm not centered. This is not the right path for that item. The alias is just that. It's again a new mistake, but I'm not going to restart. It was not working this initialization. These values was not sent, and I have realized that it was my mistake to put to change the part of the item ID that is not the right one. Okay, next time we will. Next time I restart, I comment that it was working. So in the item tree, now we can have my bar numeric in value 200. So it should be doing my room to be now working and counting that. That's it. So, okay. Now the question is to do some examples, real examples or useful examples with the LUA scripting. So I will do 2 or 3 examples. First, as far as I remember, yesterday or Monday, we got some information from here. Many of these is totally understandable, but there were 2 elements like sunrise and sunset that was without format. This is a raw value of the sunrise and the sunset, so I don't know what it means if I don't do an analyze of this. So this is possible to do using a script. So I will do this now. We need 2 items to write the result of the conversion, because we have to convert this to a real date and time. And this conversion, in this case, only time of the day. This conversion is done to a specific item. So if I don't have that items, what I can do first is create items. So I can create virtual items. Virtual branch was here for something, one, and now is the time to create that item. So I will do 2 virtual items first. So I will go to the extensions menu, the virtual item definitions, and I will create 2 definitions. Time sunrise, maybe geo folder, for example, and a description. Time for sunrise. Data type, of course, is time. Readable and writable, and that's it. And the sunset. And that's it. And this is the items I need now to execute my script, of course. So I will save. Okay, it's starting again. Now we should work that. Turn on off the lights of the last practical board, I will tell you. And what we need to do is a conversion between the raw data that comes from the HTTP to my formatted data with hour and minutes, for example. So the script, I will do it now, is done one per time. It could be a generic one, but I want to do it 2 times because I want to show you how it's done. So after this is restarting, we can do, because it will be not necessary to do it again, this restarting. The items are there, so the next steps to do is the scripting and the invoking of that. We need to invoke that scripting using a task. So we will see both things in the same process. But now this restarting to create the virtual items is necessary. So some seconds and then we can start. Okay. Looks like it's now leaving again. Yes, here we are. So we have to create a function. I can promise that the lights have been turned on, but I don't want to turn on the camera because we waste a lot of space from the video recording, so it's better not to show it for this. But it's on. We can show in the item tree that my alias room 0204 central off is in value true, so it worked. I will turn them on off again. Sorry, alias. Okay, now they are off. So let's go. Let's do one script. I have, let me check the virtual items are here. Yes, time sunrise, time sunset. Okay, we have my items here and the other items were here. So we have both, yeah, we can see both in the same screen. Fantastic. So we can see the result after executing this script. So first, close this window. I have examples.lua, so I can do my functions here. So to create a function, let's give a name for that. Function is a word that is reserved for the Lua. So let me, for example, call it sunrise. The brackets are for the possible parameters you may need. So in this case, we are not going to use any parameter, but it could be in another examples. Then I define a variable, for example, time sunrise, and this is the value that we are going to get the value for this variable from the source. So there is a definition for this. I think it's source value. Yes, source value. So we get from the source value that. And the destination will be another variable that is called sunrise, the destination value, okay, is, and here is the conversion. I have to take the OS date, operating system date, and the format. If I want this date in hours and minutes, I have to do this and take it from my variable time sunrise. And the result has to be written in the destination item. So I have a source, I have a destination, and this is the combination between both. Okay. So NXA dot write destination value, I think, yes, it's right destination value. the result that is called sunrise, the variable sunrise in the destination. This is the function. So we have to end this function. So this is the function I will use for the sunrise. How to use a function? This is the second question. I will come back for the sunset then, but this is copy paste and change something. So I will restart this. So this function should be now working. Okay. And what I have to do is to use this with a specific source and with a specific destination. So let's use a task for this. Task is similar as what you have seen from the very beginning. It was the virtual links. You may remember that we have a source. Look the name of the column: source item ID, destination item ID. So we get some specific virtual links that I deactivated, or some others I still they are still remaining because I use it for the, I think, for the today information. Yes, this and this, I think this and this, it was the virtual link. So that's the virtual link for that. So, but the virtual link is just a source and destination. There is nothing to explain or nothing to configure between them. If this source is changing, the destination item ID is written with that value. It's a bit more sophisticated than you may think, because if you have different formats between the source and the destination, the system is intelligent and can do a conversion, intelligent conversion. So for example, you have 1 byte in the source and 1 bit in the destination, you will have 1 if the byte is higher than 0 and 0 if it's 0. So it's intelligent in that way. Somehow you can do this kind of things. But the tasks are more sophisticated. So a task is the thing that I can use. Let me delete this and create a new definition. Between sources and destination items to do some complex things. What is the source destination I am interested in? The source item I am interested to convert is this item, because this is a raw value and I would like to have it with the format that I have explained before. And what is the destination for this item? It's a virtual item I have created. So this was the reason why I need to create a virtual. Okay, on receive, yes, true means that when you receive in this source a new value, execute the thing that I am going to configure now. On send is nonsense, because I am not going to force change the value manually. But if you are going to change the value manually in other examples, you should configure this as true. It's nonsense in this case. And if somebody sets values, also it's true by default, so don't touch this. You have the possibility to create a delay for this execution. It's not interesting in my case. And this is the sophistication of this module. What to do? You can write directly value. It makes nonsense, because I want to do a conversion between both values. If I write, I just get the same value in the other one. I can write a specific value. It's nonsense. Set a specific value. The difference between write and set is you write to the real field, the real world. For example, you turn on a light. When you send a set option, is just to change the value in the BMS, but not send into the real world. Okay. You can also send red telegrams, but in my case, my example is to send a script. And I am going to put here, what is the script I want to call? The function was sunrise. That was my function. So I just save. And if I take a look, let me check. Sunrise, yes. We have to wait, of course, to get a new value of this. Yes, if you don't have the new value, is not possible. So I can force to red, but we need to wait some minutes, because if this value is not changing, we don't execute. It's only when you get a new value, bang, then you execute this. So every 15 minutes, we will check afterwards if it's working. The only thing we can do is to create an example for the sunset. It is really not necessary because it's exactly the same script. But if you want, we can create a specific for sunset. Sunset, this is the name of the function. Time for sunset is to get the value from the source, and the destination, also called sunset, is taking that from that variable, and we write sunset in the destination. So this is more or less the example I wanted to show. And this is not necessary because it's exactly the same script, but with different global variables. So it could be also called from here, but we can also create a copy. Okay, sunset here, and the destination is a virtual variable that is called time sunset. And well, this is by default true, and the same, we just have to select a script that is called sunset without parameters. And saving, it's enough because it's not necessary to do anything more. So we have to wait, repeat, in order to get this working, because I get this information every 15 minutes. So I have to wait for the next time we get the value from the real world. But okay, let's do another example. So for example, I remind you that we have some data, for example, from Modbus. Imagine that the voltage, for example, is 100 times more than the real one, because it's an integer, and they give you the resolution, multiplying the value for that resolution, they give you an integer. So this is the way that Modbus normally works. And if you want to have the real value, you have to do something. So what we can do is a script to convert one source in a destination, dividing by 100 or multiplying by 0.01. So this is the example I will do also. So we can do this the same way. So first, we need some item to write this value. So we can do it in a virtual item. Why not? Let's do it. Virtual item are created in extensions virtual item definitions. I will do only one example for this because we have the logic module, and the logic module is the right thing. Sorry, not sure. No, the right tool to do these kind of things. I will show you afterwards. So time for sunrise sunset, and now voltage. Okay, I will say path metering, for example, one folder for that, and the real value of the voltage. Okay, this is the item. It should be not an integer, it should be a float, for example, read and write, and that's it. We have our virtual item now. I will restart afterwards. I will save, but not restart now, because I want to create the example first, so then we restart everything afterwards. So what to do if we want to do a conversion? It's a new function, for example. I'm not writing, no. function, and let's put the name multiplying factor multfact, for example. And in this case, I will put a variable. The variable, we can call it factor or whatever name, factor, for example, because we can use this script for different cases. If you want to multiply 10 times or 100 times or 1,000 times, or divide by 1,000 or whatever. So you can reuse the same script for any kind of example of that. And it's very simple. We just have to take to write in the destination value the source value multiplied by the factor. So we just have to put exactly this. I have to write, there is a specific string for this. In the destination value, I just have to write in the destination value the source value. So the source value multiplied by the factor. And that's it. This is my function. Very simple. Very simple. I don't. In this case, as you have seen, I haven't used global variables or local variables. I just write directly on the fly to the destination value, take the source value, multiply by the factor, and write it in the destination. This is exactly what I need. So I'm just doing this. I will define the task, but I cannot define the task if I don't create the item. So I will create a new one with a different factor, for example, energy, okay, because the factor was different in the same folder, metering real value of the energy. Of the energy consumption, it will be also float, for example, it's enough. But if you want to double, it's not a problem. And now, yes, I will save and restart to get these two virtual items. And after that, I will use the function for the multiplying factor two different times with two different factors, because the Modbus is giving me two different factors, so it's not a problem. So let's wait for the restart. So I will close this window, not this, because I need to create the new tasks with this new function. So we can now create a new definition. So what is the source? The source is my Modbus item and the serial line input register voltage, okay? And the destination is my virtual item metering voltage, okay? And what I am going to do is use a script that is called multfact, and in this case, multiplying with this factor. This is the parameter factor. And then I can copy paste. I think it's easier. No, it's the same. My Modbus input register about energy with my virtual item during energy, okay. Okay, and to the script, but in this case, the factor is 100,000 times. So we need 4 zeros. Okay. Multfact. Okay, I think it's perfect now. save and check. Let's check virtual. And that's it. You get the values corrected. And let's check this. No, we haven't yet. My information from sunrise and sunset, maybe in the next minute. But this, I repeat, this is not necessary now because we're wasting a lot of time creating virtual items. It's not a problem because you have a lot of virtual items in your license, but you need to create a task and you need to know something about Lua, etc. Why I'm telling you that is not really necessary? Because we have another new tool that is called the logic. So in my modules, we have my logic. The configuration is not complex. It's explained here that this is the name for the variable for the calculation. So we will use value, for example, as a reference for my calculations. When you have to send something or to process with the output, it's with add value add. Language setting by default is multi-invariant culture, so it's not necessary to take this. Nothing. Just to remember that value is the name to use. And the important thing is that table called parsing definitions. So if I want to do exactly the same examples as before, okay, what we are doing with this table is creating items together to the original items, but corrected. So for example, if I wanted to create the voltage okay, let's say okay with the suffix okay, we can have a base path. It's really not necessary in this example because this is for the if you have to do massive conversions for several items together. So in the next example I will show you, but not now. And what I just have to put is the selector. This is the item I want to convert. It's very simple. This is the item I want to convert. My Modbus item with my input register with the voltage, for example. Okay. The data type is not a string. It should be a float. Okay. And important is the in calculation function. So what we have to do in this case is multiply the value, so that's the reference, times 0.01. That's it. And on the fly, without needing to create a new item and just saving, if the definition is okay, that it looks that it's okay. If we take a look on the Modbus serial line input registers, we have the voltage with a prefix because the register original is 2, but this is 2.OK, for example, with this corrected value. And it's taking you much less time than before. So this is fantastic. This was really easy because if I copy paste, I'm very good, as you can see, copy pasting. I can select, for example, this other one, the energy, that is this value, and I'm just putting here the factor for this case and saving, and at the same time I'm getting, well, I think yes, I have this without the need to restart the server. So this is fantastic. But this is not the only thing I want to explain, because we have another example very interesting to show you. We can do this also in a massive way. If you have several similar items to convert, you can do it in one definition, and that's really fantastic. For example, we have my alias with all my rooms, and you know that here I have my temperature of my rooms. That's it. This is the temperature, but this is in Celsius degrees. And why not? Maybe I am interested to have this in Fahrenheit, for example. So the conversion from Celsius to Fahrenheit is known, is multiplied by 1.8 and add 32. So this conversion is very simple. So what the question is how to do this massively, because I have this, and the only thing that is changing between this temperature and the temperature of this room, for example, is these values. The one is now 2 and the 1 is now 4. So this intermediate number is 1, 2, 3, or 4 if you have 4 floors, and this room number also from 1 to 4 in this case. So we need to define this variability of this item ID, and the only thing to do is only one definition in the parsing definition, and that's okay. So let me do it for you. So the example should be, okay, the suffix, let me put in this case Fahrenheit to indicate what I'm doing. The base path in this case is not really necessary because the items has a very small path. They are alias, and as you remember, the item is, I will copy this. The item is exactly this. This is the item, one of the items, okay, but I have to do, instead of 2, I know that there is some variability, so in between brackets I put from 1 to 4. This is the floors in this alias that I have. In reality, we only have 2 floors, but we created alias for the other 4 floors, 3 and 4. And the last number, again, it is from room 1 to room 4 between brackets. And just take care with this because backslash has to be written double again, in this case also. So we will get, or the system will search for all the definition that matches this, and you will see this in the comment, that is 16 is found. And then we just have to create float, for example, and the calculation is, okay, I take the original value, this is the name that I have to put, multiply 1.8 times and add 32 degrees. So if I save, look, it found 16 source items for the base path, and the parse definitions are okay. So what happened? If I'm coming here to the alias and any room, I have my temperature in Fahrenheit in this room or any of the rooms. With only one definition, we can create 16 temperatures, for example, in the Fahrenheit. That's really, really fantastic because it's just a second, and you just have to know the specific format for that thing. So if you take a look on the, and this was the thing I would like to show you, in the knowledge base, you can see how to do this magic. The logic module is what I mean. So, and this, there is some examples here, and this is one of the examples I have used. Is this is the Fahrenheit definition. So this is a different example because I have to, well, this is a single one definition, and this is the example with this base path. For the example that my colleague Wolfgang shows you, mine is different, so I have to include a backslash, double backslash. I had to take care of that in the selector because with a single backslash it was a mistake, and I realized that I need double as an LUA, but it's just the only detail to take in account. And you have these examples, fantastic. Also, an example very, very interesting to use the module with a MQTT broker that is giving you the information in JSON format. So you can extract information from this item that is a string with a lot of information, but you can extract specifically information using that parsing definitions, asking for the specific resource in second level here, and so on. So the knowledge base is a fantastic tool for you to really understand and take an advantage of all these tools that we have. So it's really nice. So at the end, we save time for creation of the virtual items. We save time for the creation and the prone error possibility to using the scripting and creating tasks, and with its logic and the parsing definitions is much more easier and faster than before. But we have both possibilities. This is the best thing. So then this was another tool to show you, and the last one, and very important, is the XLogic. So we will split the explanation for the XLogic between this and the next session, because I don't want you to be here half an hour more, and I think we have enough time for the last things to explain. So I will start with XLogic with a small explanation of what we can do with XLogics, for example. So and I will do first approach with another LUA example for you. Let me combine LUA with the first XLogic approach first. So let me create on the fly a new example for LUA. Okay, so my examples here, and I will create a function, because the example I want to show you is calculation of the number, for example, the number of the lights that are on in a practical board, for example. So how to do this calculation, because we can know the status of one light. That's it. It's very simple. Let me do it in KNX. Why not? It's simple. The status of a light, on-off status, is very simple to know. But this is a Boolean. This is, I have 1, 11, 12, 2, 3, 4, 5, 6, 7, 8. So I have 10 lights here, up to 10 lights. So the status of the light is just indicating me that if the light is off or on, for example. Okay, so I would like to know how many lights are on in a number, or even as a second example, what is the power that these lights are consuming, estimated power, with a number. So to do this, I'm afraid that we need a conversion first from the Boolean to a numeric value. How to do this in a very easy way with a script? Why not? We can create a small script that it could be called Boolean to numeric, for example. Function B2N, for example, Boolean to numeric. It is a new function. And I'm going to use a comparison. If the source value, so I will show you another way to do this. I can get value of the source item. So that's it. This is equivalent as the source value I showed you before. It's the same. So if I take this value and is equals true, for example, then I will write in the destination value, but I will do it also using classical form. Write value in the destination item ID, and the value I assign for this is 1. And else, if it's not happening, this is very simple. I copy this and I write value 0. So I am converting a Boolean to a numeric. I end the if and I end the function, 2 different ends, for the if then else and for the function. This is a function to convert Boolean to numeric, very simple. I get the value of the source. If this value is true, then I write in the destination the value 1. If not, or else, I write 0. It's very simple. So this function has to work. I can test very simple. If I save and restart the scripting module, we can test it very fast using the tasks, you may remember. And maybe you may think, okay, but what is the destination? I am not going to create virtual devices for this. I am going to use, for example, the status of the light, not from the alias, because I can do it from KNX, and using my bars. I have bar. Okay, which bar? Numeric. The destination has to be numeric. So I will start with variable 11. And what I'm going to do is just invoke a script that it was called P2N. So this is the more or less the typical situation. And the best thing is that it's very simple. To do this and change just these values, because my KNX strategy was very clear, and it was from 4 to 8, from 1 to 8 for the binary, and the dimmers were 11 and 12. And my numerical items to write this down is this. So it's very easy to do this. I am again doing an example for you in Lua because I want to combine it with the XLogic, and then we can finish today's session, second session, sorry, and continue in the last one. And we use for this the same scripting. So we are reusing 10 times this scripting. So I save this and we just have to test it. How? Okay, let me open here. Let me open here my bar, numeric, okay. And here it's easier if I take from the room the central off for the lights of the room. So if I send on, so you see that every of these numbers are 1 or 0. The question is now, it's working fantastic. The question is now to know the number of lights every time. So to do this, I will use XLogic. An XLogic that is already created. I'm just going to show you this module. If I press the XLogic button, I get a sort of mini game, I could say, a mini game that is called the XLogic. And this is a tool to create new commands, of course, and we will do it in the next session. But now I'm going just to use an XLogic that is already created. So we have a lot of modules. Some of them, as you can see, for example, this is Spanish word. This curso is training in Spanish, visibility user or whatever. So we can create our own XLogic. So you can see here some of my XLogic, but some of them are also, many of them are already created. And one of that is the math add. This logic is already created and give me the possibility, if I'm just opening to show you, that it's a logic that can have up to 10 inputs, fantastic, because we need 10 inputs, and 1 output to write the result. And of course, if the name of the logic is add, I guess it's adding all the numbers that comes from the inputs, of course. But this is defined here. So we have the calculation result is the add multi of all these items or whatever. This is not necessary now to take a look on this. It's just to explain that there is a XLogic already created with this. It's not a trivial XLogic. It's very complex and sophisticated, this example created by my colleagues, because there is a previous condition. I'm just telling you that there is a previous condition asking if the quality of the items is good. And if you want to evaluate this quality, then only if the quality of all the items is good, I will do the calculation. If not, you decide if you want I do the calculation or not. So this is what you can see here. The quality is good for all of them, okay? Or you have decided not to verify the quality, okay? Then I calculate the result. So only in these two cases. If you want to check the quality, or you don't want to, and the quality is good, or you don't want to check the quality, then we go to the command and calculate it. If not, it's finished. So that's it. And it's not just adding. We can create a XLogic to add 10 items, but this is already created first, and second, it's very well and much powerful than we can create the one that we can create before. And the second question is, what do you want to do with the result? Do you want to write it to the bus, or just set the value in the server? So this is different to write or to set. But the question is, okay, this is only the editor to create this kind of logics. This is not the place to use it. For use the logics, we just have to go to a specific folder, a specific menu, sorry, that is called in the extension the XCommand event definitions. So this is the only thing we need. It's empty. And define number lights room 0101, for example. No variables in this case. The type is, and this is really also very powerful, on every input change, for example. This is the typical on input change, but it could be every 20 seconds if you select this, or when a value is rising, falling, changing, going above a limit, below a limit. So it's really fantastic. But in this case, I just select this, or maybe trigger on start if you want, on input change. And the X command to choose is the one of the many of I have here. The math add is the one to choose. And now we select, I want to execute this specifically for these variables, numeric 11. Well, I'm going to use all. So by default, only two are put here, but I can copy and paste. That is faster than and in a few seconds, we will see the result of the addition using a specific XLogic command. And the output, let's see, why not? Put it in the 10, in item number 10, so in the top of this. Just say, okay, save, and then we can see if somebody changed the values of the lights, for example, like me. Again, we will see the calculation here. 10 lights now on, no lights on. Maybe I can also turn on only one light, or maybe another one. So now it's 2 lights on. So it's working really fantastic. So we can see how this is working. I will show you the last example because this is very interesting. So we can go ahead with the last XLogic in the next example, because I want to do this much better. This is good, but this is not enough. So I will copy this function and paste it and change the name. Okay. The name with parameters. The function with parameters, for example, to give not only true or false means 1 or 0, 1 light, 2 lights, because maybe it's okay to know that I have 5 lights on, but maybe there are simple spots and other lights are 1000 watts consumption. So we would like to know what is the value for on, and this is a parameter that you can put here, value for on, and that's a different thing that enrich your explanation. So value for on, okay. So to do exactly the same example, I can change this, and in the task definitions, I will change this B to N, okay, And imagine this light is 10 watts, for example. Let me check. Underscore. Okay, 10 watts. And the second one is 100 watts. And the third one is 60 watts, for example. So what I'm going to do is just, and the rest I will put 10, that doesn't mind. I will change the last two. So what we are doing is just improving our example, because this is an example, maybe you can think it's not useful, but imagine that you have, for example, floor heating with different surfaces, square meters. So you can know with the Boolean status of the demand, what is the real surface that is in demand in one building, for example. This is just an example, but I think it could be useful. So the status is just telling me in this numerical the value of that. So we can trigger that and check if it's working. Let me have this open and then this open, and then if I turn on the light, we get values and we get the sum, the addition of that. And if I turn off, the first was not working because it was already on, but now it should work. 220 watts, that's good. If you turn off the light number 12, for example, it's 50 watts less, 10, 100 watt less, whatever. Okay, so that's working fine. And that was the last explanation. So we have seen several examples with scripting, function creation, different things. Let me check if we have now that working. Not yet. Maybe there's some mistake on that definition. I will check. Okay, I will check. We have seen how to create a multiplying factor, how we use this in the tasks with a source and a destination, combining that. And if I have some more complex things like XCommands, that we have many source and one destination, we can use with the complex XCommand options that we will develop in the next session. So thank you very much for your attention again, and see you in 1 hour and 40 minutes about. So thank you. Bye.